Hello friends, in this video we are going to see selection sort algorithm. So let's see how this selection sort algorithm compares with other sorting algorithms. Selection sort algorithm is one of the worst time complexity algorithm, since if you look at the best, average and worst cases of this algorithm, the time complexity is n square. N square is one of the worst time complexity for any sorting algorithm. And space complexity wise, it is O of 1, since there is only one temporary variable required to swap the elements, which might need more space to sort and list. So let's take a look at the algorithm. So when a list is sent as an input, there are two loops. The first loop iterate over the list from 0 to n, the length of the list, as I. Index of the first element is assigned to a minimum variable, and then this minimum variable is compared with the rest of the elements in the array. And if you find any other element which is smaller than this, then the index of that element is assigned to the minimum variable. And then at the end of the inner loop, we swap the elements. So the first element of the outer loop is swapped with the minimum element that we found in the inner loop. And then we keep doing this until we exhaust the counter. And at the end of the outer loop, we would have a sorted list. We saw some optimization technique for quicksort, but here we won't be able to find any optimization, because there is no way to figure out whether the given array is already sorted or not. So because of this, we have to exhaust the outer loop, and this is the reason the best case of this algorithm is also n square, and we are not able to have a better time complexity compared to average or the worst case. Let's take an example. So in the first iteration, 4 is going to be assigned the minimum index variable, and then 4 is going to be compared with the rest of the elements. And if you take a look at it, 1 is the minimum element out of the entire array. So in this case, 1 and then 4 would be swapped after the inner loop completes. And in the second iteration, we are not going to consider 1 because it is already in the correct place. So we are considering from element 2 to element 7. And 3 is compared with other elements. So 3 is compared with 5, 3 is smaller. 3 is compared with 2, 2 is smaller. And then 2 is compared with 6, 2 is smaller. 2 is compared with 4, 2 is smaller. 2 is compared with 7, 2 is smaller. So the first element of the array 3 for this outer loop is swapped with 2. So if you see here, swapped, and then 2 comes here and 3 goes there. Similarly in iteration 3, we are comparing the elements in the gray boxes, and then if we find out that 3 is going to be the smallest element of this, then we are going to swap 3 and then 5. And in iteration 4, we are comparing 5, 6, 4, 7, and then 4 is the smallest, so we are swapping it with 5, which is the outer loop element. And then we are going to compare these three elements, 6, 5, 7. 5 is the smallest, so 6 and 5 are swapped here. And in 6 and 7, 6 is the smallest, so 6 retains the same place. And the last iteration, we don't have any other elements to compare with, so we retain the element, and then the outer loop completes because we have done n iterations, and the list is also in the sorted order. Let's look at the implementation. So in Java, in a method, an array of integer would be given as an input, and then the array of length is assigned to a size variable, and we iterate over the elements I equal to 0 to I equal to I less than size minus 1, because index starts with 0, so you cannot have I less than size because it might go index out of bounds exception. And then we take the I variable and then assign it as min ix, because this is a minimum index variable. So we are iterating over the index, and in the inner loop we iterate over I plus 1 to the end of the array to figure out what is the minimum element. So we compare the array of j less than array of minimum ix. So every element in the inner loop is compared with the ith element, the element of the outer loop, and if we find any element which is less, then we assign that variable. And then this part is to swap the element at the end of the inner loop. And let's see how it is implemented in Python. In Python, we are going to have same algorithm as two for loops. The first for loop is going to run from 0 to the size, and then we are going to assign it to a minimum index variable, and then we are going to have an inner loop to do the comparisons. So every element in the inner loop is compared with the element in the I, and then if we find any element less, then that element's index is assigned to minimum of ix, and then at the end of the inner loop we do the swapping of elements. So since you saw there are like two for loops, the algorithm takes a time complexity of n square, and then temp is a variable that is being used to swap the elements, which is the reason we have a constant space complexity of O of 1. And that's the end of this video. So if you like this video, please subscribe for this channel, and if you want to learn more about other sorting algorithms, then please do subscribe to show your support. Thank you.